Hello everyone, I'm Han from Tsinghua University. I'm very pleased to have a chance to introduce our work about a review and outlook for relation extraction. Our main idea is to look back at existing relation extraction methods and announce key challenges and show some promising directions of relation extraction to make more powerful relation extraction models. First, I would like to introduce the backward information about knowledge and relation extraction. To acquire knowledge, there are two main approaches. One is to reason knowledge in knowledge graphs. For example, we know that Wang Xiaochuan and Chinese Zhang were the students of Tsinghua University. We can reason that they are anonymous. In fact, this approach is to extract the structured knowledge from the structured data. The other approach is to conduct relation extraction, in other words, to extract relation between entities from text. For example, from a single we can know that the Jobs found Apple from the text. This is an approach to extract structured knowledge from unstructured or semi-structured data. As compared with knowledge graph competition, to extract knowledge from the text is easier to acquire new knowledge from text like new entities and new relations outside knowledge graphs. So many efforts have devoted to this field because of this and to explore the relation structure models to get information from the text. As deep learning has been widely used in recent years, the neural models have been also widely proposed and studied for relation extraction. As compared with the statistic relation extraction models, the neural models are more effective, and the results on the benchmarks are growing fast. However, this doesn't indicate that the problem of relation extraction has been solved. In fact, there are still some challenges. The first, existing methods focus on highly limited predefined relations. The second, they require sufficient cumulative data to train their models. The third, they mainly extract relations from single sentences, and last, these methods serve for specific domains. In fact, to extract knowledge from the text is complex. First, to get large amounts of cumulative data is expensive. The second, there are many long-tail relations and entities. It is hard to label sufficient data for them. The third, many facts are mentioned by multiple sentences rather than single sentences. And last, the growth of relations and new domains require relation models to face more open domains. All these challenges cannot be solved by existing methods, and to follow these directions to handle problems may lead to more powerful relation extraction models. So I will introduce the above-mentioned promising directions in detail in the following part and show some promising methods. Mm, the first, the manually labeling data is expensive and cumulative-intensive, so an ideal method is to align existing knowledge graphs and text to auto-label large-scale data for training models. In other words, to apply the distance-supervised methods. However, the main problem of distance supervision is the noise in the data. How to reduce the side effect of the noise in auto-labeled data is a key problem. To better train relation extraction models with noise data generated by the distance supervision, the existing methods apply various models to automatically select informative examples from the noise data, like the selective attention models. To further improve the effect of selecting examples from the noise data, various spatial attention models or reinforcement learning methods and adversarial training methods have also been proposed. Although the above the denoising methods have been widely explored, their effectiveness is still limited. In recent years, there have been some new trends to apply more data for relation extraction, like to use the heterogeneous information like knowledge graphs to enhance the performance of relation extraction. Or some methods may use the new heuristic rulers to generate more powerful distance supervised data. Some methods will use the training methods more suitable for the noise settings like contrastive learning. And to apply the pre-trained language models are also very useful for relation instruction. All these new trends are effective to consider more data for relation instruction. The real-world relation distributions are long-tail, and only the common relations can have sufficient training instances. Most relations just have very limited relation facts and corresponding sentences for training a model. From the figure, we can see the long-tail relation distributions on two sample datasets, where many relations even have less than 10 training examples. So we introduce the featured learning for relation instruction, which focuses on learning models with only a few training examples. To support the research work of the featured learning for relation instruction, we build a large-scale featured relation classification dataset, the FieldReal. Moreover, we apply the metric learning and the meta-learning methods for featured relation learning. The metric learning methods can learn how to measure the similarities between long-tail relations, and the meta-learning methods can learn how to learn these featured relations. Both of them can work well for those long-tail relations. And moreover, we explore some more complex featured relation learning settings, like the noise featured learning setting and the domain adaptation featured learning setting. We have explored the hybrid attentions for the noise featured setting and explored the pre-trained models and adversarial training for the domain adaptation featured setting. From the figure, we can find that the existing featured models cannot handle these um, more complex settings, and here still requires further efforts to solve these hard problems. And the third directions for more powerful relation instruction is to consider more context because the one document may mention many entities and there may be complex cross-sentence relations among these entities. So we want to consider more context rather than single sentences to extract relations. From the empirical analysis, we can find that the three abilities are required for considering more context for relation extraction. The first is to understand the long-term texture data. This can make our model be more suitable to read the long documents. The second ability is to pass information across the entities. And the last ability is to conduct multi-hop reasoning in the text. To this end, we propose document-level pre-trained language models, which can understand long-term texture data and pass information across entities and conduct multi-hop reasoning in the text. But from the experiments results, we also find that there still remain some problems for further efforts, and more work should be conducted to help model to have these abilities to help the instruction models to extract information from the known documents. The last direction to lead the relation extraction to more powerful models is to consider new domains. As new domains, entities, and relations are growing in the real world, so due to this, we argue that to explore open relation extraction is meaningful. For open relation extraction, there are three challenges. One is how to detect new relations. The second is how to expand new data for these new relations. And the last is how to continually learn these new relations. And for relation discovery, some methods have explored to learn the metrics to measure the semantic similarities between sentences and then use the learned metrics to cluster the latent relations like the example in the right figure. And for automatic data expansion, some methods propose the bootstrapping methods to iteratively use the seed examples to expand the training data from the unsupervised data and use the expanded the training data to train a model for the new relations. For continuing relation learning, some memory-based methods have also been proposed, and all these methods can work well to continue learn the new relations. All, uh, all these above methods are preliminary, and here also require the further exploration for open domain relation instruction. Here we give a summary of the four promising directions towards more powerful relation instruction we think, and um, we argue that all these directions can make the relation instruction models to become more better. Of course, there are still some other challenges and interesting findings for relation instruction. The one is that some analysis has shown that the existing relation instruction models focus on remembering the entity name rather than understanding the textual semantics for relation instruction. In our paper in this year's MLP has shown this. If you are interested in this, you can read our new paper for details. The existing datasets for relation instruction are also not the fine grained enough to support the various relation instruction settings, and this is also a serious problem to advance the research of the relation instruction. And we hope the more datasets can be constructed to support the further efforts. We hope our view can advance this field and inspire more efforts in the relation instruction community. And thank you for your listening, and welcome for any questions. Thank you.